Are you ready? So page 144, we'll look at this one. Question 8. In a game, a person is given a choice of 2 bags to take a bead from. The person wins if they choose a red bead. Is it better to take a bead from bag A or bag B, or does it matter? So we'll look at the probability of the bag A. So we have 3 reds out of a total of 5. And what about bag B? How many reds have we? 1, 2, 3, 4, 5, 6. 6 out of a total of? A total of 10. What's the problem? Is it better to do A or B?
Same.
It's the same. 3 over 5 is the same as 6 over 10. So the chances of picking a red are the same, aren't they? Alright. Question 9. A letter is chosen at random from the word mathematics. What's the probability? So what are the count all the letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in mathematics there are a total of 11. What's the probability of choosing an M? 2 over 11. Okay, next question. What's the probability that a letter is either A, E or an I? So an A. 1, 2, 3, 4 out of 11. What's the probability the letter is not a T? So count the T's and then reverse it. So there are 2 T's. 9 out of 11. So not a T. Alright. Now what we'll do is we'll move on to the end of that. Maybe a question on the next chapter. Perimeter and area. What does perimeter mean? Yeah, so we'll look at this one. This is a good example, this one here. So we have 2, 2, 7, 5, 4. Alright, just looking up. Thanks. How do we get the length of this one? Well, I know the total length is 5.
2 plus 5.
This is 2. Yeah, 2 plus 5, so that is 3. How do you get the perimeter now? The back? So add them all up. So start here. Perimeter, 7 plus 5 plus 4 plus 3 plus 2. 7 and 5 is 12, plus 4 is 16, plus 3 is 19, and 2? 21. Alright. So perimeter is walking around it, the distance around it. Now we'll have a look. Area is different. How do you get the area of, let's say, a triangle? Oh, how do you get the area of this shape, first of all? How do you get the area of that? You divide it into 2 shapes, don't you? So this is 4 by 4, which is 16. This is 2 by 2, which is 4. Add the 2 areas together and you get a total of 20. All right. What about a triangle? How do you get the area of a triangle? If you count that, that is a base of 6 and a height of, that's a height of 4 squares. How do you get the area of a triangle? What's the formula?
So you go 3 and 3.
It's half the base by the perpendicular height. So this is the base. So half the base multiplied by the perpendicular height. What's half the base, Kyle? 3 times, what's the height?
6.
Perpendicular?
4.
It's 12. Alright, let's have a look at another way. Another way of getting the area of this triangle. Watch. If I make it into a rectangle, and I go 6 times, what's that height?
4.
Get the area of the rectangle. 6 fours is 24. And then just divide it by 2. 12. Same answer, isn't it? Area of that is 12. Do you understand both ways? Here's another one. Here's the triangle. The base is 7 and the triangle goes away out there. This is the perpendicular height. The perpendicular height is 12. So again, how do you get the area of a triangle? Half the base, which is 7, times the perpendicular height, which is 12. So it's half 7 is 3.5. 3.5 times 12 is 42. 42, if it's centimetres, it's centimetres squared. Right, so that's area and volume. And then we moved on to, okay. We'll look at another question. Geometry, lines. So, what's that called? From one point to another and I draw a line. It's called a line segment. Okay. If the line continues on through the 2 points, what's it? It's called a. That's called a line. All right. So what else do we have? We have, what if it starts at A and it goes through B and it keeps on going and there's an arrow there? That's called a ray. And how do I write it? Bracket A B. The bracket shows where I start. I start at A. Okay. And if I do that, what's it called? Bracket B. It's a ray BA. All right. What's this angle called here? What? Name that angle. Acute. This angle here is 90 degrees, which is also called a right angle triangle. If the angle is greater than 90 degrees, it's called obtuse. And if it goes beyond 180, it's called a reflex. So if you open the book too much, it's reflex. On this clock here, there's one to remember. On this clock, there's 12. 12, 1, 2, 3. Right. Can you remember how many degrees were there? That's good to remember. Looking up. That's 30 degrees. That is 60 degrees. This is 90 degrees. That's something good to remember for your revision. Okay, naming angles was another one. Some of you are not paying attention. Naming the angles. Name that angle. Angle ABC, CBA. What's important about the B? It's in the middle. And another way of naming it? Angle B. There's another way of naming it. All right, and this question here, which is on page 171. We'll go with an easy one first. Between 8 and 12. There's 1, 2, 3, 4. Yeah. So it's 4 times 30, which is 120. Here there's a gap of 1, 2.5. 2.5 times 30.
6.5.
So 30, 30 and 15, which is 75 degrees. Here between, there is 1, 2, 3.5. So 3.5. That's 90, 105 is correct. Okay. All right, and then we moved on to questions like this one up here on page 173. See this one up here? That angle is 180, isn't it? So what's A?
110.
A here is? It all adds up to 180. A is 20. Watch. 37. What's A? So you take it away from 180. 143. 143. Okay, and here's one here. So that's 60. So you add 60 and 87, and you have to find out what x is, don't you? 33. X is 33. Okay, what does this? That means it's 90 degrees, isn't it? And that's 76. So 1976, 70 plus 76 is 166. And take that away from 180. What? 14. X is 14. All right. As another type of question. So if we have, keep looking up, 140 and 90, you have to find out what B is. The whole thing is 360. So 140 and 90, 140 plus 90 is 230. All of that is 230. Take that away from 360, 130. So B is 130. Right. Another type at the bottom of page 173. These are the slightly harder ones. We've got, we'll look at each one of them. Right, that's 90, and it's saying that this one is 3x. Well, you know that this is 90 degrees, don't you? 3x is equal to 90. Now, how do we get rid of the 3? Divide both sides by 3. 3 divided by 3 is 1. So x is equal to 30. So 3 times 30 is 90. The next one. So there's another one here. This is 60, 2x, and x. They all add up to what? X plus 2x plus 60 is equal to 180. They all add up to 180. What do we do next?
You add the x plus 2x.
Yeah, and I got 3x. What do we do with the 60?
Take it away from 180.
Take it away from 180. So I got 3x is equal to 120. Divide. I want to get rid of the 3. X is equal to 40. So this is x is equal to 40. 2 times 40 is 80. Right, a bit easier. Getting there. All right, and we'll do one with the 360 on page 174. Page 174. So question 9, part 3, page 174. So we'll do this one. So we have 90, 4x, 2x, and 3x. All right, you figure out what x is first. So it all adds up to 360. So we go 3x plus 2x plus 4x plus 90 is equal to 360. And we add up the x's. 3 and 2 is 5 and 4 is 9x. And we move the 90 across. 9x is equal to 270. Divide both sides by 9 because I want to get rid of the 9. X is equal to 30. So 2 times x, 2 times 30 is 3 times 30 is 4 times 30 is 120. Okay. I'm going to stop that one for a sec. So that was chapter 8, 9 and 10 so far. But actually, what we'll do is pretty quickly. These are parallel lines because those arrows say that they're parallel. And what are these angles up here? Well, that angle and that angle. So that's top left. TL top left. TL top left. So they are corresponding. Corresponding, remember, means so they're on the same side, top left and top left. So if this one is 30, this one is 30. What can you tell me about the angle, this angle? What's this one called? This one's called opposite. Opposite angles are also equal, aren't they? So opposite angles. So these two angles are the same, these two angles are the same. Corresponding. And what happens if you're looking for the Z shape? So again, two parallel lines. The arrows show that they're parallel. And what if I put a transversal? What's a transversal is they're train tracks. What if I put a broomstick across it? That's a transversal. Look for the Z shape. So if I look for the first Z shape, that angle is the same as that angle. So this is my Z shape. Okay, so that's one way of looking at it. And what the other case is, I can put my Z like this. So this angle is the same as that angle there. So what are they called? They're called alternate. Alternate angles are equal. Right, so maybe we'll look at page 178. There's a good question. We've covered it before, but there's a triangle, page 178, questions. This one here, this question here. So we have an angle up here which is 36. We have an FE, we have a 72, and we have a G. The three angles should add up to, in a triangle first of all, three angles add up to 180. Looking this way. Three angles add up to 180. So if I add 72 and 36, what do I get? So 70, I get 108. And take that away from 180, 72. So this one is 72. Alright, so it shows in the diagram that this line, they're parallel. So if I rub out that for now, I know that that's 72. There's my Z shape. So if that's 36, what's E? 36. Okay. And I'll put that back for a second. That was 72. This is corresponding angles. That's 72. This one is also 72.